Welcome back. In this video, we're going to look at section 5.5, which continues our look at application problems solved using systems of equations. And in this section, we focus on mixture problems. Once again, the problems in this section can be done using single variable methods, but as we'll see here, you can also use two variables for them if you like. So let's start with this problem about tickets at the zoo. So it says the ticket office at the zoo sold 553 tickets in one day and made $3,936. We want to know how many $9 adult tickets and how many $6 child tickets were sold. So first of all, what is a tip-off that can tell you that you can use a system of equations to solve this? One is we're looking for two things, how many adult tickets and how many child tickets were sold. That's one thing. Also, there's kind of two different attributes or kinds of quantity in this question. A number of tickets, which is just a number, like you can count on your fingers, how many tickets of each type were sold. And also each ticket has a value, that is a dollar amount. So there's dollar amounts and then also quantities in here. And then also, we know basically there's a couple of sentences in here that kind of can translate into, each translates into an equation. So the fact that there are 553 tickets sold, let's go with A is the number of adult tickets and C is the number of child tickets. Okay. The 553, that will be A plus C. The number of each type of ticket added together gives 553. The second equation is about dollars. And so the 3,936 that the ticket office made is $9 for each adult ticket times the number of adult tickets, and then $6 for each child ticket times the number of child tickets. So we're multiplying the number of tickets times the price per ticket, and that gives us an answer in dollars. And so this will be our two equations in A and C that we'll be able to solve. So for this one, it looks like it's going to be one that we could do using substitution, or actually elimination is better for this one. The second equation, though, looking at the 9, the 6, and the 3,936, I think that we can divide all the coefficients in our equation by 3 at least, and that'll make the numbers smaller. I'm going to keep the first equation the same. And the second equation will divide 3 by 3. So this will give us 3A and 2C. And then 3936 will be 1312. Is that true? I better check just to be sure. Yeah, I felt kind of weird dividing from left to right, but there you have it, 1312 for that. All right, so now we're going to use elimination to do this. I think if I multiply the top equation by -2, we can eliminate C's. We could eliminate A's, but then I have to multiply by 3. Multiplying by 2 is a little easier. So we're going to multiply the top equation by -2. So we'll have -2A minus 2C, and that's equal to -1,106. Okay, 500 twice is the 1,000, 50 twice is the 100, and then 3 twice gives the 6. Okay, so 3A plus 2C is equal to 1312. Okay, so we'll add. This will give us A. There are no C's. And then 1312 minus 406 is 206. So 206 adult tickets. Okay, now that we know how many adult tickets were sold, we can subtract from 553 to find the number of child tickets. Okay, so it looks like 347 child tickets and 206 adult tickets. Okay, looking back over the system of equations that we had one equation that was about a quantity of tickets. The second equation was about dollars. Okay, let's try another one of these. Here it says Mary has a bag of quarters and dimes with a total value of $8.55. And then it says the number of quarters is 3 more than twice the number of dimes. And then finally, the last sentence just asks us to go solve the problem. We need to find out how many dimes and quarters Mary has. Okay, so I'm going to go with D for number of dimes. And then Q for the number of quarters. You can use X and Y if you like, but if I use D for dimes and Q for quarters, it's easier for me to remember. Okay, so the total value, the $8.55, it will be 10 cents for each dime, so that's 0.10 times the number of dimes, and then quarters, 0.25 times Q. So 25 cents for each quarter times the number of quarters. And that's the dollar amount question, or part of the question. And then the second sentence, the number of quarters, that's Q, is 3 more than twice the number of dimes. Okay, so we're having Q is 3 plus 2D. That's the second sentence. So this will be our system of equations. We can solve that. We could solve that by substitution. I think that will be probably easiest. So let's go ahead and do that. I'm going to substitute Q, or 3 plus 2D, in place of Q in the first equation. So we'll have 8.55, it's 0.10 D, plus 0.25, 3 plus 2D. Okay, so there's an equation just in D's. So now, here, if you want to, you can multiply to eliminate the decimals. For now, I'm just going to leave them in at least until I remove parentheses, and then I'll decide about the decimals after that. So we have $8.55, 10 cents times the number of dimes. Distributing the 0.25, we'll have 0.75 plus 0.50 times D. We can combine like terms. I'll actually also subtract 0.75 from both sides. Okay, so 855 minus 75, that's going to be 780. And then we have 60 cents times D on the right. All right, so then if you take and divide 7.8 by 6.60, you'll get 13 for the number of dimes. Okay, once you have the number of dimes, you can figure out the number of quarters by substituting into this equation. The number of quarters is 3 plus 2 times the number of dimes, which is 13. So that's 3 plus 26, or 29. Okay, so 29 quarters. And 13 dimes. Okay, and then if you want to kind of check that, we could do that. So 29 at 5 cents a piece would be $7.25. And then 13 dimes is $1.30. That would be $8.55, which is good. And then the number of quarters is 3 more than twice the dimes. Dimes is 13, times 2 is 26, plus 3 would give the 29. All right, so that checks out. Okay, so again, looking back, we ended up with 2 equations and 2 unknowns. One equation was about dollar amount. The other equation was about a quantity of coins this time. Last time it was about a quantity of tickets. Okay, here's 2 more. The first one's about nuts. Here it says Paul wants to make 5 pounds of a nut mix using peanuts and cashews, and he's going to sell that for $6 a pound. If peanuts are $4 a pound and cashews are $9 a pound, we want to know how many of each type of nut Paul should use. Okay, so of course, just trying to think about the problem for a minute. If he used cashews that cost him $9 a pound and he turned around and sold them for $6 a pound, that would be foolish, right? If he used all peanuts at $4 a pound, he wouldn't be able to sell them for $6 a pound. So he must have to have some cashews in there. So it's going to be a blend of both. Let's try to figure out how many of each type he's going to use. So the variables here are going to be C for pounds of cashews, And then P will be pounds of peanuts. Okay. So he's going to make 5 pounds of mix using peanuts and cashews. So that tells me that the pounds of peanuts plus the pounds of cashews has to equal 5. That equation is about the weight of the mix in pounds. And then the next equation is going to be about money. So the peanuts are $4 a pound. So he'll spend 4 times P on peanuts. And cashews are $9 a pound. So he'll spend 9 times C on cashews. And that'll equal the price of his total mix, which is supposed to sell for $6 a pound. And he's making 5 pounds. So this is a sum of products, right? The 4 and the 9 and the 6 are dollars per pound, and the P and the C and the 5 are all pounds. If you think about it, if you're multiplying a rate like that's in dollars per pound times some number of pounds, the pounds units are going to cancel, leaving an answer that is just in dollars. Okay, so that will do it. There's our 2 equations and 2 unknowns. We're going to go ahead and solve that next. So what would be easiest? We can actually do elimination on this one. So I'm going to eliminate p's. I'll multiply the first equation by -4. We'll have -4p minus 4c is -20. And then for the second one, we'll have 4p plus 9c is 30. Adding those two together, the p's vanish, and we're left with 5c is 10. And so that c is 2. Okay, it says p plus c is 5, so that means that p will need to be 3. Okay, so he's going to use 3 pounds of peanuts. And those cost, I'm just going to check now. Peanuts are $4 a pound. And so if he uses 3 pounds of peanuts, he'll be spending $12 on peanuts. He's doing 2 pounds of cashews, and they are $9 a pound. 2 times 9 is 18. So he'll be spending $30 on the peanuts and cashews, $12 for peanuts and $18 for cashews. He's going to end up with 5 pounds that he sells for $30. If it's 5 pounds for $30, that's $6 a pound. Okay, so that works out. Of course, realistically, if Paul is going to be making this mix and selling it, he'll sell it for more than he pays. Otherwise, he's not making a profit. But that complicates the problem a little bit. So we're ignoring that, assuming he's just breaking even. Okay, this one sounds really technical, but you'll see that it's not as bad as all that. This one is about percentages, though. Sometimes people have a little trouble with that. So be careful. So the story here, it says Alicia needs 150 milliliters of a 30% solution of sulfuric acid for a lab experiment. 150 milliliters, 30% solution. She only has access to a 25% solution and a 50% solution. So she's going to mix those. The 25% is too weak, the 50% is too strong. She's going to mix a little bit until she gets the exact 30% that she needs. So there's the question, how much of each of those 2 ingredients she should use in order to make this happen. Okay, so I'm going to make X be the number of milliliters of the 25% solution. And then Y will be the number of milliliters of the 50% solution. Those are her 2 raw ingredients she's mixing, kind of like the peanuts and the cashews. Okay, so we're mixing those 2. And so the total amount that she needs to end up with is 150 milliliters. So the X plus Y has to make 150 milliliters. This is about the total amount of fluid volume, not about the amount of acid mixed into it. So this is total fluid volume. Okay, so the next equation is actually about the acid in there. She has this 25% solution. So 25% of X, that'll be the amount of acid that comes from the 25% solution. The Y is 50%. It'll be 50% of the number of milliliters of 50% solution. And that should equal what she's trying to make, which is 150 milliliters of a 30% solution. So 0.30 times 1. Okay, so you'll notice our equation here is a product plus another product equaling a product. That structure is something you'll often see in working with mixture problems. Okay, so the tricky part usually is setting this up, but we'll still be careful as we go through and solve this. So probably we'll end up using elimination. We'll see on this. The first thing I'm going to do on the second equation, though, is divide through by 0.05. And that's to simplify those coefficients a little bit. At first, I was just going to move the decimal point over to make them whole numbers, but then I noticed 25, 50, and 30 are all divisible by 5. So I'm going to divide by 0.05 on that just to make the numbers nicer. Our first equation stays the same. 0.25 divided by 0.05 is 5, so that's nice. And then 0.50 divided by 0.05 is 10. And then we'll have 6 times 150 on the right side. Okay. So now our coefficients are all nice whole numbers, so that's good. Okay, so we're going to next multiply our first equation by -5 to eliminate x's. So we'll have -5x minus 5y, and that is -5 times 150. And then copy the other equation. All right, so here you'll notice I didn't bother multiplying the 5 times 150 or 6 times 150 because I didn't actually want to. And it's going to be okay because we're just going to combine those anyways, and we'll see that that works out nice. -5x plus 5x is no x's. -5y plus 10y is 5y. And then 6 times 150 plus -5 times 150 is going to be 1 times 150. And so that will give us just 30 for y. Okay, if we know that y is 30, then going off of this equation, x plus y is 150, that's going to be 120 for our x, right? Okay, so keeping track of what everything was, we're going to use 120 milliliters of the 25% solution and then 30 milliliters of 50% solution. It makes sense that she's using more of the 25% solution. If you think about it, she's got a 25% solution and a 50. She's trying to combine and she wants to make it the 30. And so it makes sense that she's using more of the 25 as it turns out. Okay. Just have one more. Okay, this one is about interest and stuff. So let's take a look. Interest, the simple interest formula is I is equal to P times R times T. We should remember that. And then for this is all about what happens in 1 year, right? The amount of interest she paid last year. So for this, we'll just take the T to be 1. Okay, so I is equal to P times R. All right, so here it says Laura owes $18,000 on her student loans. There's a bank loan and also a federal loan. So I'm going to go with X as the bank loan, the amount of principal, and Y will be the federal loan. Okay, the 18,000 then must be the total of those two loan amounts. Okay, so that covers that sentence. The interest on the bank loan is 2.5%, and the federal loan at 6.9%. She paid 1,006 last year in interest. That would be the principal times the rate in each case. So for the bank loan, it was 2.5%, so 0.025x. For the federal loan, it was 6.9, so 0.069 times y. Okay, so that is our system of two equations. The total principal was 18,000. That's the bank loan plus the federal loan. Then 2.5% of the bank loan, so 0.025x, 0.069y for the federal loan. And together that made 1,006. So we're going to need to think about how to make this, how to solve this in the easiest way possible. I was at first thinking of moving the decimal point over 3 places to get rid of the decimal points. We could do that. I was thinking actually of just substituting, just jumping right in. Maybe we'll do that. What would be nicest? I didn't want to move the decimal point over a bunch of places because down on the 1006, that makes it like a million, right? I just didn't feel like dealing with the big numbers. So instead, we're just going to use substitution. Okay, I'm going to make x be 18,000 minus y. If you want to use elimination, go ahead. I just didn't feel like it this time. So we'll have 0.025x, but x is 18,000 minus y, and then that's 0.069y is 1006. Okay, so now we need 0.025 times 18,000. And that's 450. Minus 0.025y. I have two equal signs here, and I shouldn't. This one should have been a plus sign. Okay, plus 0.069y. That's equal to 1006. Okay. All right, so now we can combine like terms. So 0.069 minus 0.025 is 0.044. And that's 1006 minus the 450. That's like 556. And that's 12,636.36. Okay. And so that was why we wanted the principal amount for each loan. So I'm getting 12,636 for the federal loan. And so we'll subtract that from 18,000 to get the other principal amount. And that's like 5363. 63. Somebody lost a penny in there due to rounding. And that was the bank loan. All right, that takes us to the end of that. Let me know if you have any questions, and have a great day.